As lead Ewaves developer, I understand your team is close to releasing your next major version. That's pretty exciting.
Yeah, we're pretty excited about it. This version's been the culmination of many years of work. And, up until this point, the Ewaves project has always been in a beta mode. So version 1 was actually never released, but we had a later version after that that was version 2, which was basically a technological rewrite of the old program, but not a theoretical rewrite. With this version, we're looking at the theory with a fine-tooth comb, and we think that this next version will be able to take the beta off of it because the bar for that is basically having it count as well as a human expert. And so it's a pretty high bar, but we're pretty confident that this next version is going to meet that bar. And so we'll have the first, release version of Ewaves out.
And when do you expect to release?
Well, we're getting pretty close right now. So what we have going on at this moment, we have a version that's running. The analysis process is not giving us a massive amount of detail. It's kind of like a low detail version of it. So the last step in this process is getting that detail up. And once we do that, then I'm going to be maintaining an internal website at Elliott Wave International. And basically, Ewaves will run every day at the end of the day, and it'll produce charts on a huge array of markets at multiple different zoom levels. And so basically, analysts will be able to go in, take a look at that, and any market they care about, they can take a look and say, well, what does Ewaves think about this market and get its opinion, and hopefully it'll be a really useful tool. And then as part of that process, there'll be some polishing because I'm certain once we start running it live, we'll start seeing any kinds of the remaining issues. There's a few quality things that I know I need to address that we'll be doing, but I don't think that'll take a very long time. Most of the stuff we've seen so far looks pretty good, but we do need that final kind of polishing phase before we release it as, like I said, the first full release version.
So right now, the currently available version of Ewaves is version 2 beta. Will this next version be 2.1?
Well, originally the next version was going to be 2.1 because it was going to be an iteration on version 2. But one of the things that I wanted to do with this version was really update the theoretical aspects of how the model worked. So the version before this was a technological rewrite of the original version, where basically we took what the people who worked on Ewaves before I did had done, and then we modernized it, made it run really fast, took all the bugs out, but the underlying theory of how it worked was the same. This version, we basically took the whole thing apart and said, we need to rethink every aspect of this, and we need to make sure that it is all theoretically as good as it can possibly be. And so it ended up being such a big undertaking to do this that we're going to call this version 3 now, and like I said, it'll be the first version that it's not beta.
It sounds like this has been a long time coming.
Yeah, it's been a very slow process to get to this next version. Originally, like I said, we thought it was going to be a fairly quick thing just to improve some various aspects of 2.0, and that's why we wanted to call it 2.1, but it ended up being a really, really major rewrite of the theoretical foundations of the program. So I would say, part of the issue is that Ewaves is a research project as much as it is a software project. And so with this version, what we wanted to do was not so much say, how do you program Elliott Waves or build a program that does Elliott Wave analysis? That's the second half of the question. The first half of the question is, what are Elliott Waves? And we wanted to answer that question really, really well before we did question number 2. So this is, I'd say, the first version where we've actually gone back and done that part of the equation.
What are Elliott Waves?
Well, that's a really good question. So, previous versions of Ewaves, we basically did a consensus type of model where we went around and talked to the analysts and said, what do you think about the various aspects of the rules and the guidelines of the Elliott Wave principle? Obviously we had the book and we had immense amount of experience from analysts who've been studying tons of different markets, and are very familiar with the history of them. And so that was a very good place to start for those versions. With this version, we decided to take the rug out completely. And what we did was say, okay, let's start with just the things where we have 100% consensus on as a baseline, and then start pulling what we called iconic counts at the time, which are basically they're historical Elliott wave counts that are pretty much unambiguous. Like, we have enough historical context where basically nothing the market does can invalidate the way we label that pattern. So, for example, we wouldn't use a currently unfolding wave on a market as a historical example. We want something that happened back in the 1930s that was a segment of a market, let's say, where, nothing today is going to change the way we label that chart. So that's a really good kind of historical chart. And so we built up a large database of these historical iconic counts, which is still growing every day. I have a guy that's doing this pretty much full time, and he just did like 10 counts the last couple weeks. And it's a large, difficult process because there's a lot of vetting that goes into these. It's not just a, label a chart and hand it over. It's, we got to check all the context on it. We run it by multiple analysts, and now we're even vetting it with the program itself. So it takes quite a lot to put this database together. But what's cool about it, once we've had this database in place, is it's served this kind of dual purpose. On the one hand, it's allowed us, the initial reason we built it was to test Ewaves and say, well, does it even label things the way we expect? We need to have some examples for it to test on. But then what it actually ended up morphing into was we said, okay, Ewaves to this point has been what's called an expert system. It's basically a program where you talk to an expert and you build the program to model the way that that expert thinks. And what we started incorporating is a little bit of machine learning, which is basically just a more dynamic approach where it can learn a little bit through the examples that we provide. So as a result of that, what it's allowed us to do is to basically, like I said, approach Elliott waves from a fresh perspective, look at them statistically, as opposed to talking or discussing them, or with a human analyst. We now kind of have this database that's an oracle for Elliott wave statistics that's been extremely valuable for building this next version and really taking the theory to the next level.
It sounds like there's a lot of new technology behind this version.
Yeah, definitely, and it's been kind of a snowball effect. Like I said, it started at small because we were starting to come up with new ideas for Ewaves 3, and we just wanted to test them. And then from that, we got the database, and then from that, we started to get the machine learning going, and then from that, the program started helping us disambiguate some stuff that we weren't that certain about. Because once you can model things statistically, you know which things are extremely likely and which things are unlikely, and you start saying, oh, wait a moment, the way we thought this market should be labeled probably isn't the right labeling because, we only have one example of this out of, 700, 800 examples. But if we change it this way, now it adheres, and it's no longer some bizarre thing. It actually looks similar to these other things. So it's been kind of a process, I guess, of kind of rebuilding the Elliott wave theory from the ground up, with a kind of a more of a mathematical basis, I guess, not purely visual, but taking the visual aspect and converting it into hard numbers. That's kind of what we've been focused on with this particular version. So, and what's been nice about it is we've found evidence to me that really says Elliott waves absolutely are real. Just the stuff we've been seeing with coming out of the model, to me is very compelling. So if there's any doubt in my mind before about Elliott waves, there certainly isn't at this point.
The database helps both you and the program learn about Elliott waves, as you've said. And you mentioned that it's also used for testing. What do you mean by that?
Okay, well, the database is basically, like I said, it's a set of these Elliott wave patterns, and all of them are completed patterns at the highest degree of their structure that we store. So basically what that means is you have a 5-wave move, and we actually store the entire thing all the way up through the end of wave 5. So at the end of these moves, there's a major move in the opposite direction that the market's doing that's going to be commensurate in time and magnitude to the move that came before. So what we have the program do is we do these macro level tests of the analysis engine in Ewaves, where basically we take in this historical time period in various markets, and then we pull that into Ewaves, and then we have it analyze it, and then it tells us, do you think that this pattern is done at this point, and are we at a major juncture where we're about to turn, or is the market not ready to turn and it's just going to continue going in the same direction? And so by doing that, we get kind of macro bird's eye view statistics of about how often Ewaves can recognize an important juncture and how often Ewaves says, nah, I don't think it's topped here, even when maybe it has topped, you know.
Can you give us any hard numbers?
I can, because those are things that I measure on pretty much a daily basis. You know, as every time we make a change to the program, we look at all the database of markets, see if markets have changed the way they're being analyzed, and what does that new result look like. Now, keep in mind, these are all in sample, and what that means is, you know, if we have a particular database that we're looking at, obviously when we target good numbers for that database, you know, there is some fitting effect happening there where, you know, if you were to take some market that we've never studied and never incorporated in the database, the odds of it performing as well on that set of data is not as high, because we just haven't, you know, used that as an example before. But the in-sample things, what we're seeing is with these junctures is it's close to 3/4 of the time when the market says, or when the program identifies the juncture correctly and says the market's going to move, you know, in the opposite direction. And then about 1/4 of the time it misses it and the market continues higher. But like I said, that is in sample. We've done quite a lot of work to reduce the degrees of freedom, which basically means de-curve fitting the program and saying, okay, you know, like I'll make changes that actually make those numbers worse on purpose, because what I really care about is not really those numbers on the historical data. What I really care about is what happens when it sees data it's never seen before, and that's more important. So those numbers are subject to change all the time, and it's possible by the time we release, I will purposefully make them actually go down even more, because I want to make sure that, again, I'm making the program as generic as possible and able to count Elliott waves on any data set with accurate theory and not, you know, fit to any particular set of data, basically.
Do you think you can keep improving the accuracy?
Yes and no. Like I said before, there's kind of two forces at work here. You know, you want the program to be as accurate as possible. You also you want to make sure that as you're making the program more accurate, you're not just fitting the data. What we want to do is discover more aspects of the Elliott wave theory that apply generically to all timeframes and all financial markets, and get that as good as possible. And if we improve the accuracy that way, then for sure we want to do that as much as possible. But in terms of just getting the numbers higher, that's not my immediate goal, because, you know, like I said, I don't want to just make it run really well on the DAX, for example, and then have it not work as well on the Dow or something like that. You know, you want to make sure that it's generic, and that's really, really important. There's a second aspect to accuracy too that is really important to understand, which is basically there's kind of two different forms of it when you're talking about it. There's, you know, how does Ewaves do on the sample set that we have, and that, because these are all historical examples, we call it the historical accuracy of the program. And that's really what we're measuring when we look at the numbers, is how well did it do at predicting junctures that have occurred in the past. Although to the program, it doesn't know that that's the past, and it has no extra context, so it doesn't cheat. From the program's point of view, these historical examples are as if the program was counting in real time. But you know, that's an important measure of accuracy, and those are the numbers we want to get higher. But one thing that's just important to keep in mind, you know, the other type of accuracy is statistical accuracy. So E-waves can sometimes be wrong historically, but right statistically. And so the simplest example I can give of this, if you take a look at this chart, is basically truncated fifth waves. So, you know, you're working a beautiful impulse wave. You got wave 1s, wave 2, wave 3, wave 4, and you're in wave 5 now. And if you take a look at this wave 5, you'll see that it's kind of small, actually. It's a small wave 5. Now, what ended up happening in the market was that the market collapsed from this point right after that small wave 5. And E-waves was wrong. And I can show this to you. You know, I can run the program on it, and it says that that's not 5, that's 1 of 5. It thinks wave 5 has much further to go. So is E-waves wrong? Is E-waves doing the wrong thing? And the answer is no, because what's going on here is that is a short fifth wave. And we know from the model and all the work we've been doing and all these examples we've studied that more than likely, the most likely probable thing for the market to do is to continue higher and have a larger fifth wave. The fact that it turned down here was a not very high probability event, but it did happen. Now, could I jerry-rig the program and force it to count this historical example, correctly, where it puts the high right there and says, okay, that was a tiny fifth wave? There might be some way to do it, but you wouldn't want to do that because then you would destroy all the cases where it did get the correct answer, which is the majority of the time. So, we want the program to be statistically correct, and that's the most important thing. And that means you're going to count things wrong sometimes in order to count them right more often than you're wrong. And that's just the trade-off you have to make. Now, of course, there may be some magic new aspect of the theory that we'll run into that allows us to see when wave 5 is going to be extra short. Maybe there's some detail of the model that we're missing. And so obviously we'll always continue to explore Elliott waves more and continue to learn more about them, because if there's something nice and elegant and clean that fits in the theory that allows us to be more accurate in our predictions without just fitting to data, then we'll do that.
Okay, so your goal is not to be an oracle, but to anticipate the most probable outcome. But what about unusual market behavior? How do you handle that?
Well, there's a couple different types of unusual behavior. I'd say one type is just rare behavior. When you get something like a super extended fifth wave in a market that's a big blow off top, those don't happen very often. So those I would call rare events. And we have actually a pretty good way of handling those right now. And it's really something that any good Elliotician should be able to identify rare Elliott waves. A giant fifth wave is a rare thing, but when you study the pattern, oftentimes it kind of jumps out at you that, oh yeah, okay, that's probably the best way to put the wave labels, because there's really not a lot of other great ways of labeling that data. And one of the things that happens in Ewaves that helps us to do that is that even though when you're looking at the model, we want to go with the most probable labeling, and you'd be like, well, extended fifth waves are rare. That's not a good labeling. But if you look at the subdivisions, the great thing about them is because it's a fractal. People say often, look at the forest, not the trees in statistics. Like, you want to look at lots of examples, don't look at individual samples. But the cool thing about Elliott waves is that they're one and the same. You look at a particular Elliott wave and it's a forest because it's made up of all kinds of other Elliott waves. So if you model them all statistically and then you have all these subwaves that are composing a larger picture, as long as the majority of them are not extremely rare and strange patterns, you can actually compose them to form a rare pattern and actually say that rare pattern is high probability. So that's pretty cool. It's something that we've tested some of these rare patterns out, and it's been able to do that as long as it has good subdivisions. If you see something the market's doing that's rare and the subdivisions are crap, then basically, the program wouldn't be able to count it, but neither would a person. You can't expect it to do anything that a human would not be able to do. So that's one aspect of rare patterns and how the program deals with that. And then the other type of rare thing is basically sometimes the market doesn't trace out social mood perfectly. I mean, the whole idea behind socionomics is basically that we have shared social mood, and it's that shared mood that traces out Elliott waves, not stock indices per se. The stock indices reflect social mood, and social mood itself is what forms the Elliott wave patterns. And unfortunately, we can't, stick little electrodes in everyone's brains and measure the social mood directly and plot it and then analyze that, because if we could do that, it would be really, really useful. But so until that point, the stock indices are kind of the best measure of social mood that we have. And looking at different financial assets, especially with the amount of historical examples I've looked at, I'm just, shocked almost at how many of them have just these really nice Elliott waves that, all the way down to very small degrees. But sometimes the market will do things where, for various reasons, maybe credit conditions are really tight or something, and the market's trying to move higher and it can't quite make it, that last new high that you need to finish up a fifth wave, and the market turns down earlier than you would have thought. And so there's some cases where a human being as well as the program will throw up its hands and say, yeah, you know what, that move, I don't really know what it is. it's a blob, or it's just, we can't really put a good labeling on it. And that's okay. And sometimes we do that, and it's better to do that and tell the person, we're not really certain what this market is doing at this time. It's not clear. And it's much better to say that than to try to force labels onto something that's not clear. Especially if you're a trader, and you're watching these markets, okay, this market's not clear right now. Let's maybe not look at that, and let's go look at another market that is clear. Or maybe you look at, the time frame you're trading is 2 weeks, and that's not clear, and you can stay with the same market, but change your time frame, go down to intraday, and now that's clear. Or maybe you up your time frame to, a few months, and suddenly that's clear. So that's usually the right answer. And so the program has actually this version is very strict in terms of adherence to what we think are good Elliott wave labelings. And so, it's not going to force anything onto any data. If you see a chart and the program's telling you, we've got a pattern here, then it should be of a relatively high quality.